Hi everyone! In the last videos I showed you guys how to handle sine, cosine, and tangent on the unit circle. But you don't always have rotations that are exactly one radius away from your origin. And so what we're going to talk about in this video is how you handle arbitrary points and how you figure out your sine, cosine, and tangent of those arbitrary points. So for instance, if this is my Cartesian axis and I've got a point over here at negative 12 and 5, then can I figure out the sine, cosine, and tangent of theta? And there are two ways to do it. One way is to go back to your sort of grade 10 SOHCAHTOA, which is fine. I guess that's okay. But I actually prefer to scale it down to a unit circle, unit triangle again. Because right now hopefully it should be apparent to you that our hypotenuse here is not 1, right? If you're going 12 across the x, it's definitely more than 1. So we're going to figure out the hypotenuse first, and then what we're going to do is we're going to scale our triangle down so that the hypotenuse is actually equal to 1. Okay, I think this is kind of a cool way to do it. So to find the third side, of course, we're going to need to use Pythagorean theorem. So we're going to do short side squared plus short side squared equals our hypotenuse squared. And of course, I'm just using the magnitude 12. The negative 12 I'm not using. Although, I suppose if you have negative 12 in brackets, it's going to become positive anyway. But we'll just use the magnitude, the length of it. So that's 144 plus 25 is h squared. And this adds up to 169. So h is 13. So the hypotenuse of our triangle is 13. So here's what we can do. We can take this big triangle here, this big triangle in this quadrant, and we can scale it down to be a triangle with hypotenuse 1. And so how do you go from 13 to 1? What we've done is we've reduced by 13. So then this vertical side here is 5 divided by 13. And our adjacent side here is negative 12 divided by 13. And this is really nice because sine is the height of a unit triangle, right? A triangle with radius 1 on the unit circle. So this tells us that sine of theta is 5/13. Cos of theta is negative 12/13. And I guess tangent, we didn't actually need to do anything. Tangent is the slope, right? So this is 5 tall, this is negative 12. Your slope is your rise over your run. So since tangent is the slope, we actually didn't need to scale anything. We could have just done our positive 5 over negative 12. The only thing is you generally don't want to leave negative signs in the denominator. So we will change this to be negative 5/12. Okay, so there you go. So there's your tangent is negative 5/12, your cosine is negative 12/13, and your sine is 5/13. Cool. So you can use this idea of scaling your triangle down to be a unit triangle to figure out any sort of Cartesian coordinate triangle.